2 weeks ago, the United States made a big change to its computer weather modeling suite, specifically to the Global Forecast System, or GFS model, what we call the American model, an upgrade that was many years in the making. Now, you may recall that in October 2012, the European computer model caught on to the left turn that Hurricane Sandy took into the Northeast a couple days before the American model did. So after Sandy, tucked into a Disaster Relief Act was funding to improve U.S. weather modeling. Now, at the most basic level, a computer model has three parts. There's the observations you need to begin the forecast, the so-called initial conditions. There's the equations. For example, Newton's second law, force equals mass times acceleration. And finally, what's called the dynamical core, which translates the equations into a form the computer can solve. And that's what was recently upgraded in the American model. And this is a big deal. The GFS is the U.S. flagship long-range model. 4 times a day it provides forecasts, 16 days out. And this is the first time in almost 40 years that the model has a new dynamical core. It's called FV3, short for Finite Volume on a Cubed Sphere, developed at the Geophysical Fluid Dynamics Lab in Princeton, New Jersey. So what makes FV3 better? Well, its numerical methods run more efficiently on modern supercomputers. FV3's portrayal of the forces that move air up and down is more sophisticated. That should provide more accurate forecasts of clouds. And another advantage, especially for small-scale features, involves exactly how the model solves the equations on a grid. Now, for decades, the GFS mathematically represented all weather as waves. This so-called spectral modeling has been very successful for large-scale features such as jet streams, but many small-scale features have sharper edges. Think of a thunderstorm, for example. FV3 represents weather on a grid that can better resolve these irregularly shaped features. And the grid is flexible. Say, for example, a hurricane is heading toward the U.S. The grid can be made finer there to better resolve the storm, and coarser resolution can be used on the opposite side of the globe to balance computational time. So, is FV3 an improvement? The short answer is modestly. The evolving FV3 has been run alongside the original GFS for more than 3 years. And here's a slice of that evaluation, a comparison of the accuracy of 5-day forecasts of pressure up around 20,000 feet for the Northern Hemisphere, for each day going back to February 1st. Now here, 100% would be a perfect forecast. The black line shows the accuracy of the original GFS. The red triangles and dashed red line plot the accuracy of FV3. On most days, but certainly not all, FV3 is above the black line, indicating an improvement. But it's pretty small. On average, for the last 4-month period, from 0.889 to 0.896. Clearly, FV3, at least to this point, is not a magic bullet. In fact, even with FV3, the American model is still, on average, not as accurate as the vaunted European model. But stay tuned, not only for improvements in FV3, but for our extended forecast, which uses both the GFS and the European for guidance.